So we've learned how to solve several kinds of equations so far this semester. We've got linear, we've got quadratic, we've got fractional, we've got rational exponents. So we're going to learn a couple new types this class. And if we don't finish tonight, we'll finish them up Wednesday. So we're going to expand or generalize our view of quadratic equations first. So suppose I gave you the equation x squared plus 2x equals -1. How would you go about solving it? Make it equal to 0. So I would have x squared plus 2x plus 1 equals 0. Factor. This factors to x plus 1, x plus 1. Set each factor to 0. Which you don't really have to do it twice because it's the exact same thing, and you get x equals -1. So now I'm going to give you another equation. Y plus 3 squared plus 2 times y plus 3 equals -1. So what does your intuition tell you to do right here? Start to distribute. Square that y plus 3. Distribute the 2 times the y plus 3. Combine like terms. Okay. I'm going to have you go against your intuition so that I can teach you a fun little shortcut. So we're going to say let, for just a minute or two, I'm going to replace y plus 3 with a new variable, maybe x. Let x represent y plus 3. So now, instead of saying y plus 3 squared plus 2 times y plus 3 equals -1, this says x squared plus 2x equals -1. And we just solved that equation. Right? We just did a little bit of work and we came up with x equals -1, right? Okay, so if x equals -1 and x equals y plus 3, then y plus 3 has to equal -1. So I'm just going to make a substitution here. So instead of an x, replace x with what it equals, y plus 3. Which means y has to equal what? Yeah. Subtract 3 from both sides and we get y equals -4. Neat little shortcut, right? You could also get there by following your instinct of squaring, distributing, combining like terms. You'll just come up with an equation that leads to a solution of -4. This just saves us a little work. So the thing that we recognized is that the coefficient here was a 1 and a 2 and a -1. So these key pieces were the same. So that helped us use the easier equation to solve the harder one. So this is called a generalized quadratic. If it has the form a times some stuff squared plus b times some stuff plus c equals 0, then you can use our generalized quadratic, the little trick we just learned. Okay. So here's an equation. I want you to solve it using that same little trick. Okay. So my hint is pick a new variable, not x, maybe z, equal the something. X squared plus 4x plus 5, and finish solving. Okay, so if we're going to let z equal x squared plus 4x plus 5, the stuff that we're squaring and then minus 3 times that same stuff, and plus 2. So this equation, if I replace all that ugliness with a z, it now just says z squared minus 3z plus 2 equals 0, which is so much nicer, right? So much cleaner. This thing we can solve for z. It factors z minus 2 times z minus 1. So z equals 2 or z equals 1. But my equation was with x's, right? My equation said solve this guy for x. What x values make this true? So now that I have z, I go back to this equation and substitute. Instead of z equals this guy, replace z with a 2 and replace z with a 1. So this is going to say 2 equals x squared plus 4x plus 5. Right, yep. And 1 equals x squared plus 4x plus 5. Does that factor? Yeah? To what? Oh, I gotta move the 2 over. Okay, 0. Move the 2 over, and then that factors to plus 3 plus 1. And so I get x equals -3 or x equals -1. So there's 2 solutions. Then I have to solve this equation. Subtract 1 from both sides, factor the right, and I get x plus 2 times x plus 2. Set each factor to 0, and you get x equals -2, and you get that twice. No need to write it a second time. So there are actually 3 values of x that make that original equation true. And this time, we actually could not have done it by simplifying the original equation, right? When I look at this, I do not want to square it, right? Because squaring it means multiplying it times itself. That means I'm going to have to do 9 distributions. It's going to be a monster. Don't want to do it. So this shortcut is really helpful. Okay, so another kind of equation that we can solve is a polynomial equation. And other than linear and quadratic, polynomial is something that we can also solve sometimes using the zero product principle. So the idea is factor everything as much as you can. It's not going to work for every polynomial, only if they have a factor in common. So what factor do all 3 terms on the left side of this have in common? X squared. So I can factor out x squared, and I'm going to be left with x squared plus x minus 6. And then what's in parentheses there can factor even further to x plus 3, x minus 2. And then I have 3 things multiplied together, and the answer is 0. When you multiply any number of things together, if the answer is 0, that means that at least one of your factors had to have been 0. So we solve each one, we get x is 0, or x is -3, or x is 2. So we can solve equations that have degree higher than 2, that have an exponent on x higher than 2, only if we're lucky enough to be able to factor it. As of now, we will eventually be able to do lots more of them. So the goal is to try to turn whatever kind of equation that you have, try to make it look like a linear or a quadratic or a polynomial. Okay, so if it looks like something that you don't know how to solve, try to turn it into something you do know how to solve. Right? That old mathematician's trick. So for radical equation, I have x plus radical x equals 12. Okay, so we have not solved any equations with square roots in them. What ideas might you have to solve this thing? Square each side. So what is the purpose of that? Why does that come to mind? It gets rid of a square root. So let's see what happens if I square both sides. So x plus root x squared, that means x plus root x times x plus root x equals 144, right? When I FOIL those two out, I'm going to get x squared plus x root x plus x root x, so I have plus 2x root x's, and then root x times root x is x. So the idea behind squaring both sides was to get rid of the square root, right? But there's still a square root in there. So it was a good instinct. It didn't quite work out the way we had hoped it would. So what could I do instead before squaring both sides? I start with x plus root x equals 12. Yeah. So close. Get the root x on its own, because then when I square it, it will just cancel with the root. So I could subtract x from both sides. So I get root x equals 12 minus x. And now that instinct to square both sides is going to pay off, right? Because now when I square root x, I'm just going to get x. So root x squared is x, and 12 minus x squared is 144 plus x squared, right? If somebody doesn't stop me right now, I'm going to be very upset. You have to FOIL it out. You can't just square both pieces. A couple mistakes like that from the test. So I was just trying to point it out. So when you FOIL it out, 12 minus x times 12 minus x, you end up with 144 minus 24x plus x squared. So a little shortcut. So it's kind of like a little rhyme, but it doesn't rhyme at all. And I don't know why it has stuck in my head for all these years. But when I'm squaring a binomial like this, I say square the first term, square the last, square the first, square the last. Take the product of the two terms and double it. Square the first, square the last, take the product and double it. Yep. So that's, it's not really a rhyme, but that's my little saying of how you square stuff. All right, so now I can solve this equation because it's a quadratic and I know how to solve quadratics. Make one side 0, so I have x squared minus 25x plus 144 equals 0. What? Oh, I subtracted x from both sides so that I would have 0 on one side. And then does that factor? Factors of 144 that add to 25? I don't think so. Maybe, but I don't know. They're not coming to me off the top of my head, so I'm going to use a quadratic formula. Negative b plus or minus the square root of b squared minus 4 times A times C all over 2A. Okay, so we've got 25 squared minus 4 times 1 times 144 is 49. So it does factor. It's a perfect square. So I have 25 plus or minus 7 over 2. 25 plus 7 would be 32 over 2 is 16. And 25 minus 7 is 18 over 2 is 9. So the great thing about solving equations is that when you get an answer, you can always check that it's right. You should never get it wrong when you're trying to solve an equation, or at least you should know it's wrong, right? So let's go back and check. So I have x plus root x equals 12. And I'm going to plug in each solution and make sure that they're right. So if I plug in a 16, I get 16 plus the square root of 16. I want to make sure that equals 12. 16 plus 4, does that equal 12? No. Okay, so 16 is not a solution. Let's try the 9. 9 plus the square root of 9. That's 9 plus 3. Is that 12? Yes. Check. Okay, so 16, it turns out, is a fake solution. We call it an extraneous solution. Extraneous, with root word being extra, right? An extra solution. Throw it away. 9 is our only real solution. It happens because we squared both sides, okay? And when you square root something, you get plus or minus, but in the original equation, it was strictly the positive square root. Okay, so we're kind of like going backwards from a square root to squaring. But when you go from squaring to square rooting, you'd have the plus or the minus, but we only want the plus. All right, so I think we will pick up with how to solve absolute value equations next class.